Hello everybody. Today I want to talk about what's an API, microservice and components, and the whole discussion would be with respect to performance engineering only. The targeted audience are performance engineers and it is not for developers, so kindly note that. Before we proceed, let me introduce myself. I am Jyotirmayi Pola. I'm working as a performance engineering architect in MNC in Bangalore. I have over 22 years of experience when I was creating this video. I worked in various domains in telecom, healthcare, banking, insurance, defense, and in my present stint, I got an opportunity to work in aero, buildings, and industrial domains as well. I worked extensively on different performance engineering capabilities and have had experience in application tuning, hardware network, and OS tuning as well. Let's continue. Now, let me first talk about why is it very necessary for a performance engineer to understand the difference between the API, the microservices, and components. Now, unless you understand the difference, unless you know what is the microservice architecture you're having or what kind of APIs you are using in the product, how the developer has developed it, designing your use cases around it is not up to the mark. That is the word I would like to say. So you may have a lotus, you may do an endurance or a spike or whatever you do. The end of this day, if you don't know the architecture, how your system or software is built, you won't be able to design proper use cases. You won't be able to get the proper load distribution. You will not be able to find loopholes, etc. in your product unless you actually understand difference between the different types of APIs, how the APIs, what kind of APIs have been used by your developers, what kind of microservice architecture is being used, and what is the difference between a component and a microservice, for example. Various things. You won't be able to identify what KPIs, what metrics you want to measure. You won't be able to find integration issues between two different microservices or the different types of APIs that are being called by any microservice, etc. So understanding this differences and creating your use cases accordingly is one of the most critical aspects for a performance engineer. Let's understand what is an API. Now, APIs are the means to talk between two modules, to units, to products, to anything on a web or to a database or anything. So your backend systems, your batch processings also can happen through APIs. Your front-end apps, your IoT devices, your mobile devices, anything can be talking only on API. Now there are release policies. The release policies is more applicable to security and less applicable to APIs, but it is applicable for a performance engineer. You need to understand what kind of release policy is applied on the APIs, because you will not be able to understand what kind of authentication, how much time your LDAP or any other authentication methodology that you are using is going to take. What kind of release policies applied on your APIs is going to give you an understanding of how you need to call an API. Even though it's a post or a GET request, what kind of a request is making the API talk? Is it like a composite API? I'm going to talk more details, but unless until you understand that, you would be able to understand whether they are synchronous calls, asynchronous calls. Are they sequential calls? Is it one single API calling multiple APIs? What is it that is happening inside your system? So understanding this is really important. So we have different types of APIs. Broadly, the APIs are actually divided into open APIs, partner APIs, internal APIs, and composite APIs. Open APIs are public APIs. Almost every organization publishes its own APIs for developers across the world to use them and recreate their own products. Partner APIs are explicit APIs that are exposed only to the partners. So the partners, like the customers who are using the APIs, are supposed to do a proper authentication. So there is always authentication and authorization that is involved in partner APIs, which may not be the case in open APIs. Open APIs may or may not have. It is mandatory in partner APIs. So when you are testing any API, which are partner APIs, having authentication layer and authorization layer into your use cases is extremely important, because there is some time lapse or delay that is going to be caused because of the authentication and authorization layers. And it is also important to understand that when you're doing partner APIs, the partners or the customers who are using your APIs may not be in the same subnet as what you are or your application is. So understanding the network delays and ensuring you're testing the network delays and measuring it is very important when it comes to partner APIs. Open APIs on that front, even though it may have network delays, it may have authorization or authentication delays. It does not matter, because open APIs are meant to be publicized and delays are accepted, delays are understood. Whereas in partner APIs, if your end customer is not happy with the user experience because there is a delay in the network or there is a delay in the authentication, etc., then you haven't done your job. So measuring that, understanding that is pretty important. Now, what's internal APIs? Internal APIs can be any APIs that are used for communication between two databases, between your batch processing and databases, or between two modules or two components in your own application, or if there are multiple applications to make a bigger application, then it can be used for communication between interconnectivity or exchange of information between two applications. For example, if there is a platform application where you are having lots of databases, event management, processing, etc., there is an application which is utilizing the platform, then there are internal APIs. Internal APIs, you need to be careful for one reason. The size or the payload size of your API differs. It depends on what is the query criteria you're having. Is it like 1 year data that you are querying, or is it like 1 month of data, or 1 day of data, 1 hour of data? How much data are you querying, even if it's 1 hour data? It can be half a gig or KBs or MBs, and how is your application actually dealing with the delays because of this query? This is just one of an example. Understanding what internal APIs you're having and what kind of payloads it's going to call. Are there any limitations on those internal APIs, on the payloads, is very important. More than often, the developers forget to put a limit on internal APIs. So it can be used for querying 1 terabyte data or 1 gig of data. If you are querying 1 terabyte of data, it is 100% going to cause performance issues. So understanding those kinds of aspects in internal APIs and designing your use cases accordingly is very important. Let's talk about composite APIs. Composite APIs is actually a different ballgame, altogether a different ballgame. Composite APIs are used by many products, well-known products. I'll give you a few examples, but composite APIs are like a single post call or a single call, and it's a single endpoint. Your API endpoint is only one, but internally it will have a sequence of calls. The largest that I have known so far, I may be wrong, but I have known to have a composite APIs that are used not more than 25 API calls internally. Let me explain what I'm talking about. Now, I just picked up this from the Salesforce website, developers website of Salesforce. So this is available on Google. Nothing that I have stolen from anybody. So let me explain this. This is 2 calls only. And actually Salesforce is the highest that uses 25 25 sub requests. Each of this request is called sub request. There's a name for it. Now, the example which I'm showing you on the screen is a one composite request, which is actually talking about a reference account, and then it is actually creating a reference contact. So these are sequential. 99.9999% of the times composite APIs are always sequential. So if you are having 25 sub requests or more than even 10 sub requests in one composite API, it is going to take time. It is a performance delays. It's a performance loophole. So understanding composite API is very important. Now, in this example, it's actually a post request. Here, the Salesforce is actually creating a reference account. It's creating an account with a reference ID reference account. And the subsequent sub request is actually using reference account.id. The ID that is created in the first call is being used for creating a contact, reference contact. So the time in this call is basically divided into two things. One is the time that is required to create a reference account, and then an ID is created. That ID is passed on to the next post call, and then there is a contact that is actually being created and attached to the reference account. So they're having multiple, your whole response time is divided into paths. This is where you need to understand. So if your developers are using composite APIs, is there a possibility for you to break them? Ask your developers and suggest them to break them up into different parts so that it will have better performance. Or if in your composite request, there are any failures, how are the subsequent calls being reacting to it? Is your developer doing a showstopper? Let me give you an example. There are 10 sub requests in your composite API call, and 9 of them have been through. They're sequential calls, which means you have already spent time in 9 different sub requests. The 10th one fails. When the 10th one fails, the API failed, but the product or the software or the application already spent time and resources on the first 9 sub requests. For a performance engineer, this is a problem. I spent my resources, my response times are high, but the call failed. There's a saying which I suddenly remember, and it's like operation successful, but the patient died. This is exactly that. So understanding your composite APIs from your developer is very extremely important for a performance engineer when he's doing the testing. Hope I clarified. Let's talk about microservices. Gone are the years when monolithic architectures, waterfall SDLC cycles, etc. They are ancient now. They are no more in vogue. So microservices architectures are like loosely coupled, reusable components which actually work independently from each other. Now, usually microservices architectures are the cloud native architectures which are coming up in the recent world, and they can be used in Dockers, containers, and they're all independent services. Each of these services can be deployed as a separate service in your containers or on a different pod, or you can actually put 2-3 microservices on the same pod as well, or in the same container. But it is mostly on the cloud native architectures nowadays. Now, let me explain further. Why do you really need to understand your microservices? First of all, microservices have their own technology stack. So you may have multiple microservices, and each of them might have been developed on different technology stack. Like one is using Java, one is using Perl, another is using complete databases. Something else is using PHP because it is completely on the client side, web browsers or something else using Google. You never know what it is. So understanding those and how they are interconnecting between each other is very important. If you are having databases, queuing systems, event management, Then understanding the microservices architecture and how loosely they are coupled or how tightly two different microservices are coupled is a very important aspect for your performance engineering use case design. Okay, let's talk about how microservices communicate with each other. Usually it's the same as REST APIs. So the same structure what a REST API is having is what your microservices also may be communicating, but that's not the limit. You also have event streaming and message brokers. Understand the difference between event streaming and message brokers. Event streaming is usually one-to-many, and event actually publishes that there is an event like this and it actually just posts. And there is a listener always when it is event streaming, and as a listener, I don't have to listen all the time. I will listen to the messages posted only when I want to have that information and process it. So event streaming, if your event streaming is what your microservices are, then there is no saving of data. So once it is posted, it's deleted. Your sender does not save any kind of details. It's posted, it's done. And second point is there is no health checks. So it's not like, okay, I lost the packet, so you need to post again. That doesn't happen. So if you're having your products where, say, for example, in an industry or a warehouse or a building where you are giving some kinds of point IDs and you are actually, or a bank, never used in banking system, but it is used in places like this where it is general information that is posted. Loss of that information for a few seconds or milliseconds is not a showstopper. That is when your event streaming is used. You need to understand at this point of time that when an API or a microservice fails during this kind of event streaming, though there is a failure, is it critical for your customer or not? If it is critical for your customer as a performance engineer, you need to go back to your developers and architects and inform them that we cannot use this architecture. Then comes the message brokers. Message brokers, on the other hand, also are used for delaying or for conveying messages or data between two different microservices or different modules in your product. But message brokers always save data. So if there is a loss of data, the listener says or responds back with another message saying that I received 10 out of 11 packets, and the 11th packet with this header ID is missing. The sender sends it back again. This is useful when you cannot afford to lose any kind of payload, even part payload. It is used when you lose the entire payload and after 1 hour or 10 days, this listener actually again queries back. It is usually never 10 days, it's in milliseconds, but that milliseconds is where the performance engineer stands. That millisecond is where the performance engineer makes a difference to the product. So understanding your microservices architecture, understanding what technology stacks are being used, what kind of REST APIs are being used, and are you using event streaming or message brokers? And say if you're using, for example, IBM MQ, you need to understand what is the depth of IBM MQ you're using, because the different depths give you different performance values, response times, payload data times for your product. So that is very important. And microservices use protocols like AMQP, STOMP, MQTT, etc. And understanding these protocols for your microservices is very important for a performance engineer. I am not going to elaborate on these protocols in this session. There is further videos that I will make, but not in this video. But feel free to Google and understand them. They are not HTTP and HTTPS. It's only the REST APIs which are web-based that are being used in your microservices that use that kind of protocol. Otherwise, the protocol is different, and these protocols have different performance engineering and performance validation. Understanding that is very important. Let's talk about components. Components is anything and everything or a sub-element that your product has. It can be a single microservice. It can be a group of microservices. It needn't be any microservice at all. It can be a monolithic architecture and you have a functionality that is developed in a complete different product and it's a plugin. Anything and everything can be written as a component. For example, in Microsoft Word, your spell check is a component. Your word art is another component. They're all plug in, plug out. So if you don't use your word art, your Word won't fail. Your Word document, Microsoft Word document doesn't fail. If you don't use spell checker or your spell check component fails, you can still use Microsoft Word without using the spell checker. They are not showstoppers. They are individual components. They can be showstoppers as well. If your Word routine itself is failing, Microsoft Word will not even open, or you cannot open a higher version of Microsoft if there is no backward compatibility with the older version. That's a failure. But each of them is a component. For example, in Adobe, your color controls. In your Paint, your zoom in and zoom out. Multiple examples I can give you like this, but each of them are termed as component. Again, a component can be an independent monolithic architecture, or it can be a group of microservices, maybe a database and a cache system or CDN clubbing along with your web-related part of your web services on your application together is called a component. So component can be monolithic, can be microservices, multiple APIs, multiple anything, database calls, network calls, your mobile devices together. Everything is called a component. Understanding how those components are interconnected within your application will give you a heads up on how you want to design your use cases for performance testing. I hope I was helpful in explaining you the differences between what APIs, microservices and components are, and how you can the differences between all the three of them, how it helps you as a performance engineer to design your use cases as well as testing them. Thank you so much. If you like my video, if it was helpful, please do like and subscribe. Thank you.